binary mechanics. Now let's look at some predictions that result from space-time energy quantization. For example, there is a maximum energy density. Yes, a one-state bit in a size D, or now called L, locus. Whereas in your textbooks, what they present allows infinite values. How about maximum temperature? Yes, but that is at less than maximum energy density. How about maximum pressure? Yes, that occurs at maximum energy density. Your textbooks will say that maximum pressure is unknown, and that's based upon flawed equations of state. How about absolute maximum possible values, energy density, temperature, and pressure, whereas these are unknown in your legacy physics books. Concerning energy density temperature ratio, I touched on that. That's related to the Boltzmann constant, which posits that over the entire energy density range, the Boltzmann constant will allow you to compute a temperature. However, the Boltzmann constant is not constant over the range of energy density that's possible. And maximum temperature actually occurs at a point less than maximum energy density. It appears to be about 0.75 of maximum energy density. Concerning the elementary particles, in binary mechanics there are 8 and only 8, matter and antimatter, quarks, and lepton. Whereas your textbooks are going to show you at least 42, which is calculated as shown here and provided in more detail in the table legend below. All of these 42 particles are either the 8 elementary particles or compositions of them. For example, the 3 quark generations are based upon odd quark numbers in the compositions 1, 3, and 5. The meson generations similarly are 3, and in binary mechanics these are based upon even quark numbers 2, 4, and 6 of them. The lepton generations are also accounted for in binary mechanics with even quark number 0, 2, and 4. Finally, the neutrino generations are 3 from 0-state bit count, which could be 0, 2, and 4 also. We have the same 3 generations recognized in your standard model, and this is based upon empirical data and summary models rather than a precise mathematical definition showing the compositions of all of these particles from the 8 truly elementary particles. So the standard model elementary particles are 42, composed of the 8 spot-based particles, whereas 42 are considered to be elementary in your standard model. With regard to fundamental forces, 3 based upon mathematical definitions, which I mentioned above. In your textbooks, it's going to be 4, our unknown number, based upon particle interactions, an obsolete way to define physical forces. Electrostatic and magnetic forces are found to be 2 independent forces, but they're classed as one primary force in your classical force categories. The fact that we've got 2 independent forces is extremely important because they're applied in a certain order, and that order determines the effects that will be seen in the time development of the system state. In other words, this particular point here is crucial in order to have correct time development of system states in physics. The 2 EM forces implies different physics. They act sequentially in the bit operation cycle, whereas, for example, in the Lorentz force in the classical treatment, they act simultaneously, which is going to give you different results. The strong force involves bit capture in proton and electron bit cycles, whereas the quark-gluon model in quantum chromodynamics is actually just an attempted replay of the electron-photon story in quantum electrodynamics, QED. The weak forces and gravity are not primary forces, whereas they are considered to be primary forces in legacy theory. General relativity space-time curvature appears to be fantasy physics in binary mechanics. However, legacy theory, specifically general relativity, posits infinitely small things that can bend. You figure that one out. Faster than light speeds. Yes, see the faster than light paper in the Journal of Binary Mechanics. No, this is the worst fear of most legacy physicists, that there could be faster than light speeds. According to the "what have you done for me lately" criterion, can you spot the currently leading physics theory? Let's look at some milestones of binary mechanics. First, we've calculated Planck's constant. Yes, from electron geometry and the length constant L called d previously. No, in the standard model, they've only got empirical values only. How about electron intrinsic spin? Calculated from the electron bit cycle, yes, known only as an empirical measurement in your textbooks. Calculated electron mass, yes, from equation 9 in the paper Intrinsic Electron Spin, ... in the Journal of Binary Mechanics. No, it's only in your standard model and empirical and input parameter. How about the most elementary objects in physics? Yes, we've got 4 types of spot unit, whereas in your standard model you got 42 types of particles, not counting neutrinos and mesons, okay? Proton and electron bit cycles. The discovery of 2 and only 2 bit cycles. These are unknown in your textbooks. Proton-hadron bit cycle, the basis for quark color confinement. Unknown are some ragtag, worthless speculations in your textbooks. Quark color confinement, result of proton-hadron bit cycle in binary mechanics, compared to a crude strong force conception in legacy physics. Mass mechanism in binary mechanics is the probability of a bit exit from a bit cycle to another bit cycle. That is the basis for all motion, and amount of motion is related to mass. In the standard model, you've got contrived, incredible Higgs boson story, which is only a primitive, incomplete conception of the mass mechanism. How about a simple up-down spin account? Yes, see the paper Up-Down Spin, ... in the Journal of Binary Mechanics. Elemental electromagnetic resonance, defined by the unconditional bit operation, unknown in legacy physics. Poor guys. Physical model of object motion. Yes, we have a law of motion. No, not possible with infinitely small objects. Zero electron electric dipole moment. Prediction confirmed by Harvard group, compared to a silly electron as sphere model in legacy physics. Non-zero proton electric dipole moment, calculated from the proton bit cycle. This excludes some theoretical proposals in the standard model extensions. Intrinsic electron magnetic moment, calculated from the electron bit cycle. It's about equal to the Bohr magneton. The anomalous electron magnetic moment is an artifact in binary mechanics from the electron's intrinsic EM potentials, whereas in the physics literature it is hailed as a major advance in physics. Non-spherical proton shape. It's derived from the proton bit cycle in binary mechanics, and it is supported by proton scattering data. Light speed c in vacuum, shown to decrease in lower quantum densities in binary mechanics, but it's postulated as constant in special relativity. Light speed decrease at lower densities? Yes, this raises expanding universe question, but this is an apocalypse for some astrophysics theories. Superconductivity, we've shown that increased electron density occurs at low temperatures. Matter-antimatter symmetry, yes, due to ongoing processes in the present. Said to be a mystery, or a Big Bang result in legacy theory. Vacuum energy density can be studied precisely in detail in binary mechanics, but are only vague ideas of virtual things and miracles. Particle creation thresholds reported in binary mechanics, or in contrast, In legacy physics, unknown or flawed Big Bang scenarios are invoked. Temperature role in gravitation? Yes. See the paper, Gravity Increased by Lunar Surface Temperature Differential in the Journal of Binary Mechanics. Popular theories cannot explain it. Is the Boltzmann constant really constant? No, it varies with energy density as mentioned above. Yes, because the ideal gas law says so in your conventional books. Hint, try to successfully navigate past the repeated mantra that physics is the only science in which physical, logical, and mathematical inconsistencies are normal. That's the story your textbooks are trying to sell you, that all these inconsistencies are normal. But it is not. Physics is like other sciences, must be logical and consistent. I hope this little presentation has helped you take an inventory of some important topics in binary mechanics that you might want to look at as you study further. Thanks for watching.